What if your next air conditioner never broke down, never needed refrigerant, and never added $1 to your electric bill after the first month? It already exists. It is buried in your backyard, and it has been there since before your house was built. Here in America, we are spending hundreds of dollars every summer fighting heat with a machine, when the ground beneath our feet is already sitting at 55 degrees, year-round, for free. By the end of this video, you will know exactly what it is, how it works, and how to build one this weekend. The U.S. Energy Information Administration puts the average summer electricity bill in America at around $178 a month. Cut air conditioning alone, and that number drops nearly in half. At What Happened in Future, we cover the technologies that are quietly reshaping how Americans live, not the ones with the biggest marketing budgets, but the ones with the best physics. This one has been confirmed by the Department of Energy, Oklahoma State University, and a 2014 peer-reviewed study in the journal Geothermal. It works in every climate zone across the United States, and a professional version of it starts at $15,000, while the version you can build yourself starts at $90,000. Here is the difference between those two numbers. Dig 4 to 6 feet below any yard in the continental United States, and the ground temperature stays between 50 and 60 degrees Fahrenheit every single day of the year. Not in spring, not after a rainfall, every single day. The U.S. Geological Survey has been logging this since 1910. Their data shows subsurface groundwater temperatures vary by less than 3 degrees across an entire annual cycle. This is why caves feel cool in August. It is why root cellars kept produce cold for centuries. It is why your basement slab always feels chilly on a hot afternoon. The Earth is a free, perpetual, 55-degree thermal reservoir, and it is sitting directly beneath your lawn right now. A ground source cooling loop taps into it. Water travels down into that cold zone, absorbs the Earth's coolness, and returns to a simple fan and radiator unit inside your home. The fan blows across the cold surface. Your room temperature drops, no compressor, no refrigerant, no service contract. And here is the physics detail that makes this dramatically more efficient than anything the HVAC industry sells you. Water carries 3,500 times more thermal energy per unit of volume than air does. That single number explains why a passive ground loop outperforms your central air unit at a fraction of the cost. Your central AC draws 3,500 watts. Running 8 hours a day across a 4-month summer at 17 cents per kilowatt hour, that is $571. The ground loop pump draws 20 watts, running 24 hours a day across the same 4 months. That is $7.34. $7 versus $571 for the same result. A cooler room. And a 2014 study in the journal Geothermal confirmed that ground source cooling systems deliver 8 units of cooling for every 1 unit of electricity consumed. Your standard central AC delivers between 3 and 3.5. The ground loop is more than twice as efficient, even before you factor in that the passive version uses no heat pump at all. Run the full annual picture. The average American spends about $2,000 a year on electricity. Heating and cooling is roughly half of that. A passive ground loop could put $500 to $700 back in your pocket every single year from a system that costs $90 to $150 to build once and lasts 50 years. And here is the part most people miss. This same loop cuts your heating bill in winter. In January, when your outdoor air is 20 degrees, and your furnace is fighting a nearly 50-degree temperature gap to keep your house warm, the ground 4 feet down is still 55 degrees. Circulate that 55-degree water through the same indoor unit, and your furnace only has to bridge a 13-degree gap instead of nearly 50. It runs less. It burns less fuel. Your heating bill drops from the same pipe already buried in your yard. One installation, one buried coil of plastic, 50-plus years of combined heating and cooling benefit. Here is what you need to build it, all from Home Depot or Lowe's. 3/4-inch PEX tubing, a 300-foot coil, runs $55 to $80. You will use about 200 feet. A 12-volt DC pump, rated for 130 gallons per hour, costs $12 to $18. A universal car heater core, your indoor radiator, costs $15 to $25 new, or nothing from a junkyard. Add a basic box fan, PEX fittings, hose clamps, and Teflon tape, and your total stays under $150 using all new parts. Dig a trench 60 feet long, 24 inches wide, and 5 feet deep. Lay the PEX in a serpentine back and forth pattern with 12-inch spacing. Connect both ends to risers that come above ground. Backfill. Build a simple fan and radiator box indoors. Connect the pump. Fill with water. Bleed the air. Turn it on. Wait 20 minutes. Hold your hand in front of the fan. 62 degrees from your own yard. One critical detail that separates success from failure. Your loop must be at least 180 feet long. Loops shorter than 120 feet lose their temperature advantage within 3 hours of continuous operation. Go long. The pipe is cheap. Here is what you know now that most American homeowners never will. The earth under your yard holds 55 degrees year-round, for free, and always has. A loop of buried PEX pipe, a 20-watt pump, and a salvaged heater core can tap that temperature and cool your home all summer for $7 in electricity. The same loop reduces your furnace load all winter from the same one-time $90 build. The buried pipe outlasts your house. You will replace your central AC unit 2 or 3 times before that PEX coil needs any attention. $500 to $700 back in your pocket every single year from a coil of plastic pipe in a ditch. That is not a future technology. That is a backyard project. This weekend. Now I want to hear from you. Drop a comment and tell me, what is your average summer electricity bill right now, and what state are you in? I am tracking where people are actually building these, and I want your state on that map. I read every single comment. If you want to see where ground source cooling and other earth-powered technologies are heading in the next 10 years, I have already made that video. It is lined up right after this one. And if this is the kind of future-focused energy knowledge you want to keep getting, subscribe to What Happened in Future. We cover the technologies that actually change how you live, not the ones designed to change how much you pay. I will see you in the next one.